Hi everybody, this is Ms. Volcano again, continuing with the second part of our static electricity tutorial. So in the first part, we reviewed this PowerPoint presentation. We went over what electric charge is and three different ways in which object can become electrically charged. That would be friction, induction, and conduction. And for this video, I want to go over static discharge. So static discharge is actually a sudden flow of electric current between two electrically charged objects. And in a static discharge, what happens, and I'm going to show you a demonstration of this very shortly, is that negative charges or electrons will flow towards positive charges. And the object that is charged at the beginning, after the electric discharge, the object will become neutral. So let's actually jump right into this FET demonstration, which I believe most of you have had a chance to experiment with. So if we go to this FET demonstration and so you could see that initially John voltage, the man here, is neutral. So we don't, he has just as many negative as positive charges, or you can say just as many electrons as protons. And everything else in this picture is shown as neutral as well. And so you can see that as we rub his foot on that carpet, he is getting electrically charged. He is actually getting negatively charged. He now has a surplus of electrons, as you can see. How did he get those electrons? He was charged through friction. So the friction of his foot on the carpet basically transferred those electrons from the carpet into his body. So now the electrons are basically trapped in his body, and he has a net charge, a net negative charge. And when he goes to touch this door, which at this point is still neutral, okay? When he goes to touch this door, we know that what will happen as he gets close to this doorknob over here is that the doorknob will actually get positively charged through induction. So what's going to happen is that the negative charges in the doorknob will want to move as far away as possible from his hand, leaving the positive charges the closest. And then you can see that as we come closer and closer, at this point nothing's happened. And you can see that you get to this point where the distance is close enough that those negative charges, those electrons in his body, will actually discharge into the doorknob. And that is what is called an electric or a static discharge. And you can also see that at the end, after the static discharge has occurred, he is neutral again. So he no longer has that excess of electrons because they have been discharged into the door. Moving on from here, static discharge, the phenomena of lightning, is also very similar in explanation to what we just described. Obviously happening on a much larger scale, but it's basically the same concept happening, and you can see here where it's showing negative charges accumulated in the lower part of a cloud and positive charges basically through induction in the top part of the ground here. And eventually what will happen when enough charge has accumulated and the conditions are right is that charge will be conducted through the air and an electric discharge will occur, which we call lightning. Really quickly, I wanted to go over this concept of an electric field. What is an electric field? An electric field is invisible, but it is a physical field that surrounds electrically charged particles. So whenever you have a charged particle, whether it be positively or negatively charged, an electron or a proton, any charged particle will create an electric field around it. And as a result of this electric field, anything that is placed in this electric field will experience a force, either a positive or a negative, either an attractive or repulsive force, depending on the charge. As we know, positive will repel positive, negative will repel negative, and positive and negative will attract each other. The strength of an electric field depends on two main factors. It depends on how much charge we have. So the more charge there is, the stronger the field will be. And the distance to the charge, the closer you are to the charge producing the electric field, the stronger that field will be. And in physics and in science, electric fields are often represented by these field lines that look something like this. This is the field line shown across, shown around a positive charge and around a negative charge. And you will also see these kind of diagrams also showing field lines. We're not going to get into electric fields very much in this class. However, I did want you to know what an electric field is and particularly what the strength of an electric field depends on. Final thing I want to leave you with today is conductors and insulators. So conductors, as you know from our periodic table units, such as metals, they allow electrons to move through them easily, and they conduct electricity easily because of that. Whereas insulators, such as rubber, do not allow electrons to move through them as easily, and therefore they are not very good conductors. All right, I'm going to leave you here with this, and I hope you took something out of this video, and I will see you in class.